Hello, welcome to my advanced problem solving calculator created by Adam Salem for my computer science NEA project 2025. First, we are presented with a login screen in which the user will choose one of two options, new user or returning user. In this case, I will create my username to be my name, and I will choose a unique password of my choice. This will allow me to enter into the calculator. However, if I choose to go back and enter a username but forget to enter a password, that I'll be given an error. Displaying username and password are required. I will then enter I will then enter a password but not a username. And again, we are prompted with the same error. Now, going back to returning user, we shall use the username that we inputted and the password that we inputted, and this should allow us to enter. And here we go. We enter into the program. Now, what if a user enters the correct username, but a different password? In this case, we are given incorrect password. And now, what if a user enters a non-existing username? In this case, I'll enter my last name and the password of my choosing, username not found. Now, moving on from our login, I will choose to now log in properly. And here we go. We have one of two choices. First, I will start with my setup function. In this case, setup gives you two options, brightness of your screen, of which you can change, or you can increase or decrease. Of course, with a limit that is corresponding to your own device. Now, the second option is units. And these are the units that will be used in trigonometric and circle functions as stated up here. We will choose radians or degrees. Every time the button is pressed, we have a global variable that alternates. If it displays radians, then we are using radians in the desired functions. And if it displays degrees, then we are using degrees. In this case, I will go back as degrees and we will move on to calculators. First, I will choose to enter into my mechanical calculator, of which there's only one function. In this case, it is suvat. Suvat, as defined, the S is distance, the U is initial velocity, the V is final velocity, the A is acceleration, and the T is time. My distance, in this case, I will choose 70 meters. My initial velocity is 5, and my final velocity is 6. In this case, my object is accelerating, and therefore we should get a positive constant. In this case, it is 0.08, and it occurs in a time of 12.73. Now, I will choose to create a negative acceleration, which should display here. We have a negative acceleration as our object, sorry, decelerates. Now, what if I were to enter three different values? If you remember properly, I had initial velocity is 8 and final velocity is 6, and we should get the same values, 8 and 6, as we are using the same numbers. Now, a user may choose to enter three different values of which they will be given the other two, or they may enter two, for which they will be given an error saying, please enter three values. Now, what if a user were to choose to enter a string instead of an integer? They will be given an error, invalid input, please enter numbers only. In this case, we can also use our buttons. These buttons will be available throughout our calculator, as some users um, may not use a keyboard, and therefore they can just use a mouse. And this allows for accessibility, which in my opinion is greatly beneficial. We have a decimal point that, of course, appends a decimal point to our entry. And we have a backspace, as users may make mistakes, of which they can choose to go back using the backspace. Now, we will move on to my statistical calculator, in which, I'm sorry, I double-clicked statistical calculator. There are two options, central tendency and probability. Central tendency in this case is a list, a user-defined list. In this case, I will choose a list of 1, 2, 3. Now, if we view the list, we can see in our order entered 1, 2, 3. Now, what if I were to enter 1 again? Then the list will be 1, 2, 3, 1. Now, if we add up all of these, we should remember that the sum in this case is 7. And remember that the number of values in the list is 4. This will be useful later. By later, I mean right now. In this case, the mean is 7 divided by 4, as it is sum divided by number of elements in the list, and 7 divided by 4 is indeed 1.75. Now, we can choose median. The median will give the middle value of an ordered list. However, our list is currently not ordered, and therefore we use a merge sort algorithm in which the 1 will be moved on to the front as it is our minimum value, and we will be given 1, 1, 2, 3. And therefore, our median is actually between 1 and 2 as our list has an even number of elements. And therefore, our median should be 1.5, and we get 1.5. Now, in this case, a mode is the most occurring number. In this case, it is 1, of course, as there are two ones in our list. Now, what if there are two modes? In this case, 1 and 2, and we get the modes 1 and 2. Now, what if the user chooses to have a list that is unique? 1, 2, and 3, there's no mode. Then we get the message that there was no mode found and all numbers in the list appear equally. Now, a user may choose to clear, of which they can press view, but they will be prompted with an error as the list is now empty. Therefore, the user will now start entering elements into their list again, and the process restarts. Now, moving back to probability, we have three types of distributions: binomial distribution, Poisson distribution, and geometric. Here, binomial distribution, we need to enter the number of terms, 5, or the number of trials, as one may say, and the probability that each trial is a success. In this case, I can show the mean amount of trials required for one success. In this case, it is 5 times 0.25, which is 1.25. 1.25. Now, a user may ask, well, what if I only do 2 tries? And what is my probability of success that I get 2 successes in those 5 tries? Sorry, not only do 2 tries. The tries are always constant. They are 5. What if I get 2 successes in those trials? That is the probability of 2 successes in those trials. Now, a user may choose to find the mean even after inputting x. However, this does not change anything. A variance also does not require x, and therefore the variance is constant with an x or without an x. Let's wait for the variance to remove, and there we go. We have the same exact variance all over. Now moving on to Poisson distribution, we have lambda. In this case, a Poisson distribution, lambda is the mean and the variance. Therefore, my mean is 2 and my variance is 2. And if a user wants to do 4 trials, in this case, that is the probability of 4 trials with a lambda of 2. Now, geometric distribution, we have the same thing, number of trials and probability, a mean and a variance. In this case, the mean and the variance are 1 over the probability, and therefore 1 divided by 0.5 is 2. 1 divided by 0.5 is 2 for the variance as well. Now, 2 trials is the probability of success and the probability of failure. Therefore, it is 0.707106. Thank you. And now we move on to pure calculator, of which we find the basic calculator functions. Here, we will always be given our username, as the user may want to know who they are logged in as they may have 2 accounts, let's say. Now, of course, we have our angle unit, as we have sine, cos, and tan functions. Now, we will choose to do basic functions such as 5 times 5, which should give us 25. In this case, we get 25, plus a 9, and that will be 34, divided by 8, and that should be 4.5. 4.25, sorry. I'm mistaken, it's 4.25. Yes, that's correct. Now, moving on, we can use the answer, which just displays our last answer. We can also delete our last element or fully remove everything. Now, I will choose a 9. In this case, the square root of 9 is 3, and there we go, we get 3. Now, this is the to the power button. So 3 to the power of 2, so 3 squared is also 9. And there we go. We can simply go vice versa. Now, a user may choose to natural log the 3, of which they will press the ln button and they will receive that. Now, let's try something that we can check. We have Euler's number, and we put it to the power of 2. If we natural log this answer, we should receive 2. In this case, here we go, we receive 2. Now, what if a user were to enter numbers such as 100, and then log with the base 10? Now, 10 squared is 100, and therefore when we log base 10, we should get the answer 2. In this case, 2. And now let's try our trigonometric functions. In this case, we are in degrees now, so we will do 90 degrees. We will press sine. In this case, sine 90 is 1. Now, one may choose to do 5 and then, sorry. One may choose to do ln and then enter the 5 to find ln of 5. However, this is not possible and we will be presented with an error. There are 6 buttons in here that require you to enter a number first and then choose the function. These 6 buttons are natural log, log base 10, sine, cos, tan, and square root. Now, we can choose to use the pi constant, and here we go. Pi added 1 is 4.1459, etc. And we can choose to divide the number, and there we go. Now, moving on, we will go into matrices. In this case, we will be given 4 buttons. We have matrix A, which we will define matrix A. And here we go. We should choose dimensions between 2, 1, and 3, 3. That's why we only have buttons up to 3. And we have the backspace, of course, no decimal, because you cannot have half a height. Now, in this case, I will choose a height of 2 and a width of 2. I will enter the values 1, 2, 3, 4, and then I will be given a message box saying that matrix A has been created successfully. Now, our matrix A, we will have to redefine it as we have restarted our program. Matrix A has not been created yet. And in this case, we will do 2, 2, we'll do 1, 2, 3, 4. Our matrix will be created successfully, and we will press matrix A again, and we will view it. It is in this order. Matrix elements are 1, 2, 3, and 4, as we have just entered. Now, user may choose to find the determinant of matrix A, and that is -2. Moving on, we will define matrix B now, and we will choose dimensions of 2, 3. In this case, we will do 1, 2, 3, 4, 5, 6. Again, given the message box that the matrix has been created successfully, we can go back and view our matrix that we have entered. And now we will go to operations. In this case, we can actually multiply A and B. We will be given that matrix as a result. And also, one may ask, what if we attempt to do A minus B? However, due to the matrix A and B not having the same exact dimensions, as matrix B is 2, 3, and matrix A is 2, 2, we will be given this error. We can also try to add them, but we'll be given the same error as the matrix dimensions are not the exact same. Now, moving back all the way to pure again, we'll be going on to the second function, in this case, sequences. I will choose to go with the geometric sequence. Continuing from where we left off, Continuing from where we left off, we are now in our geometric sequences, of which we have a help label up here and a second label, which I will get onto later. Our first help label shows us the format of a geometric sequence, of which we have our first value as A, and our common ratios are. As the first value is A, the second value would be A times R, and the third value would be A times R squared, and so on. In this case, I will choose A to be 5 and R to be 2, and my n value will be 1. In this case, it should only give me the sum of the first value, which is 5. Therefore, sum of the first value is 5. Now, what if we choose to do sum of the first 2 values, which should be 5 plus 5 times 2, which is 10. 5 plus 10 is 15. And here we go, we get 15. Now, one may choose to leave n blank for infinity and find the sum for infinity. However, the sum for infinity requires r to be between -1 and 1. And therefore, we are given the error. R should be between -1 and 1. In this case, I'll do 0.5. And the sum to infinity is defined as a over 1 minus r. In this case, a is 5. And 1 minus r is 0.5. 5 divided by 0.5 should give us 10. Sum to the infinity is 10. And all is good. Now, moving on to arithmetic sequences. We can choose to, in this case, an arithmetic sequence is a, and then a plus d is the second value, and a plus 2d. In this case, we do not call it a common ratio, we call it a common difference, as we are increasing by d every single term. I will choose my a to be 5 and my d to be 1. In this case, I'll choose the sum for the first value, which is 1, of which I'll be given an answer of 5, of course. Now the sum of my my first two values, sorry, would be a plus d, which would be 5 plus 5 plus 1, 5 plus 6, which should be 11. And here we go, that is 11, and all is good. Now, one may choose to enter a string of which they will not receive any answers. There we go, no answers given. Now we'll go back to main menu. We'll move on to calculus. In this case, we see differentiation and integration. And here we go. We will enter the function that we want to be differentiated. In this case, 2 multiplied by x, which can be said in normal terms as 2x. The differential of 2x should just be 2, and therefore our result is 2. Now, let's attempt to do x squared. The differential of x squared, as we know, is 2x. And here we go. Our result is 2 times x. Now, what if one was to write 2x, which to a human, that would be 2 times by x. However, our calculator does not do that and will give us an error. Simplify expression, please. And so we will choose to keep it the same as what we had before. Now, moving on to integration, we will create a upper bound of 2 and a lower bound of 0. Now, I will choose to integrate x squared, which we know is 2x. In this case, 2x, if we sub in the upper bound, 2 times the upper bound is 4, and then 2 times the lower bound is 0. So 4 minus 0. Sorry, no. I've differentiated in my mind. I apologize. What we actually get is a third x cubed. Now, 2 cubed is 8. 8 over 3 minus 0 is 2.667. That is the same as 8 over 3, of course, as we will be given 6 and a remainder of 2/3, and 6 divided by 3 is 2, so 2 and 2/3. Yep, that works. Now, what if I was to choose an easier value? What if I was to choose 2x? The integral of 2x is x squared. In this case, we will sub in the 2, sub in the 0 as the lower bound. 4 minus 0, and that's 4. There we go. We can assume that this works. Now, we will move on to conversions. In this case, I will go on to computer conversions, which is applicable to our computer science A-level course. We have binary decimal, hexadecimal to binary, hexadecimal to decimal, and vice versa, of course. Binary to decimal, we will start with a decimal number such as 1, which is easy. Of course, that would be binary 1. Now, we can do vice versa. We will be given 1. Now, I may choose to do decimal 10, which is 1010 in binary. Therefore, I get 1010, and vice versa, I will get 1010. All right. Now, moving on, we can attempt to write a string, and we'll be given an error. Invalid input, please enter integer numbers only. Integer numbers means we can enter decimal 1.5 and we get the same error. Now, moving on to hexadecimal to binary, we are given 2 help labels. Max hexadecimal is FF, and max binary is a byte full of ones, which corresponds to FF. In this case, we will try the max, and here we go, 4 and 4. Try the vice versa, we are given the same. Now, what if I was to enter hexadecimal AB, which would be 1010, then 1011. 1010, 1011. And of course, the opposite way around also works. Now moving on to hexadecimal to decimal, we will attempt FF, which is 255, and that is our maximum decimal. Of course, vice versa again. We attempt AB in this case, which is 171. This has been checked through myself and an online hexadecimal to decimal converter. Now, moving on, we'll go on to metric conversions. The metric conversions are available in two parts of the calculator. They're available in pure and in the everyday part, as some of these conversions may be used in everyday life. Length, in this case, kilometer to mile and vice versa. Of course, we will do meters to feet and inches and meters to yards. Kilometers to mile, we can do 1 kilometer, which is 5/8 of a mile, which is 0.6214. That's 5/8. And therefore, we can also do the opposite, which you'll get 1. And then, of course, all of these are the same display for consistency, and they they all do different functions, of course, depending on what we are converting, but they will all look the same. In addition to kilograms to pounds, kilogram to ounces, kilogram to stone, temperature, we can have Celsius to Fahrenheit, Celsius to Kelvin, Fahrenheit to Kelvin, and of course, vice versa for all what was stated. Now we'll move on to graphing. This is a built-in function, and therefore we can attempt and we can check actually that this is correct. Now I will ask my calculator to plot the graph y equals 2x. In this case, y equals 2x is a linear graph, which passes through the origin as we have not included the y-intercept. But what if one chooses to include a y-intercept of 5, let's say? Then our linear line shifts up and our intercept is at 0, 5, just as predicted. Now, one may choose to enter a polynomial graph, which I'll enter x squared, which should output a U shape, just as I'm showing in my mouse. And here we go, a U shape. Of course, we have not included a y-intercept, and therefore we are going through the origin. Now we can assume that this works correctly, as this is a built-in function using matplotlib. Now moving on to geometry. This is the part where we use our angle units, radians or degrees. Now I will choose to do degrees for simplicity. I'll do 50 and 30, and then I will choose to include a side. Okay, now we know that the sum of the sides in a triangle is 180. Therefore, 50 plus 30, we are missing this side to be 100. There we go. We are given 100 and the corresponding side lengths. Now, what if I was to include a different, a different, sorry, a different set of inputs? In this case, 150, and therefore we should get 30 here. We will include the side, 30 degrees, and the different side length. Now, I will choose to go into radians mode. We know that the sum of angles in a triangle is pi, which is 3.14. Therefore, I'll include my first angle to be 1.5, and my second angle to be 1. And sorry, let's make it simpler. Let's make it 0.5, and therefore 3.14 minus 2 is 1.14. And we will include a random size measure. 1.14, just as predicted, and we can try a different set of results now. What we have been doing is 2 angles and a side. Now, what if we were to do 2 sides and an angle? In this case, we will do it this way, and we will be given 0.5 and 1.14. There we go. That was the same values. Now we have a consistent measure. Now, going back to circle, we will choose to do the radius. Let's choose a radius of 5. A we will get a circumference and an area. Now, in this case, we will leave theta blank for a full circle, and we may choose to enter 180 degrees for, sorry, sorry. We can choose to enter 180 degrees for a semicircle. And here we go, circumference of the semicircle and the area of the semicircle. The only difference would be that the area is halved and the circumference is halved. Now, moving back onto polynomial, we will do a third degree polynomial, as quadratic degree polynomial are simple enough to do. However, third degrees are complicated and require the use of built-in functions or a very complicated equation, which I've chosen not to use. Now we will enter different coefficients, and we will be given that our three x values, x1, x2, and x3, we will be given one real and two imaginary, as we have an odd number of x's. However, we could also get three real values, but in this case, because of our given coefficients, we will not be given. Now, moving on, we can also do a quartic, of which we will be given four x values, as our highest polynomial level is 4. x1, x2, x3, and x4. Moving on, we will go on to my everyday calculator, which is the final addition. We will go on to health and fitness, which we will do body mass index. In this case, this is the BMI scale, which is available on the NHS website for any cross-reference. First, I will do the weight is 60 and the height is 180. This will give us an BMI of 18.52, which is in the normal range. And we'll also see an ideal weight of 71.3, which corresponds to the height of 180. Now, what if the user were to be of a lesser weight? Then our BMI should decrease because our height has stayed constant and therefore we are decreasing and now we're in underweight. However, our ideal weight stays constant because our height stayed constant. Now, what if the user were to have a smaller height and a smaller weight, a shorter height and a lighter weight, I should say. There we go. Our ideal weight is changed to correspond to the height, and our BMI is increased as our weight is now normal in response to our height. Now, moving on to body measurement converter, we go back, as I said, into our metric conversions, which are just the exact same, and we can check that through here. Everything works the same. And now we will go back into financial, for which the user may enter the UK tax. This is a UK income tax calculator and therefore does not include insurance. First, I will start with a value of 10,000, which is less than the 12,500 tax bracket and therefore will not have any taxes on it. And the take home is 10,000 indeed. Now, what if the user were to have £100,000 as their yearly income, which is very generous. Hopefully, we can all reach that one day. But in this case, let's focus back on what we were doing. Our income, in this case, will have more taxes on it as it is in a higher tax bracket. And that will be our take home, excluding national insurance. Now, moving back into the interest, we have simple interest and compound interest. Our starting balance in this case, let's say, is 5,000. Our interest rate is 2.5, and our number of times that the interest rate has occurred, let's say, is 2. Therefore, our final balance is 5,250. And there we go. We will now move on to compound interest. In this case, we'll have a starting balance of 8,000, an interest rate of 1.24, and we'll say the number of times in years. In this case, compounding periods per year, whether it would be semi-annually or quarterly or anything else. We can even do annually. In this case, there will only be 4 compounds, and therefore 8,404. This has been checked through a compound interest calculator online. And that is it. Thank you for listening to my explanation of my calculator, and I hope that this user manual has been efficient.